gentlemen, welcome to our introduction to statistics. So, statistics is the art and science of collecting, analyzing, and drawing conclusions from data. What's important about this is we have this data. Data is something you need to go and collect. So, oftentimes in statistical studies, surveys are taken, or data can be collected from various sources. One of the kind of big examples right now is with the presidential election on its way. We have polling. Polling is a way of collecting data. And just for indulging my dorkiness, data is the plural. Data is a plural of the word datum, which is a word no one ever uses because you never have one datum. You just always have some data. An individual is an object described from the data set, and a variable is an attribute that can be take on different values for different individuals. So what you think of this as is anytime we're doing some kind of statistics, we're trying to study something. The thing we're trying to study is the individuals, and the aspect of the thing we're trying to study is the variables. So again, using our electron for an example, we're trying to study how the vote is going to go. So we tend to think of our individuals as voters and the variables who they're going to vote for. Okay, so again, here is an example of data collected. And we think of this column right here, the households, as individuals, right? So we're thinking of this as a way of encoding the individual's data, right? We can do this with address, for instance. In this case, we number all the houses. We can also do this with address. We can do this with zip code. In this case, we number them. So those are the individuals, and each of the columns across the top are the variables. Right, these are the variables. So for each of these individuals, we want to know something about them. We want to know about these variables. Okay. Our next definition talks about types of variables. Variables can either be categorical or quantitative. A categorical bit of data is something that puts the individual into categories. A quantitative bit of data is something that tells you about some quantity related to the individual. So normally, categorical data is represented by words, and normally quantitative data is represented by numbers, but that's not always the case. For instance, a type of categorical data would be zip code, right? So you can't just go number, not number. What you do have to think about is is it telling me about some quantity related to the individual? So in our original problem up here, we have this is categorical data. This is categorical data. And this is categorical data. And what's left is quantitative. Sometimes you'll hear me and other people say quantitative, qualitative as well. Qualitative is categorical, same idea. Okay, now let's look under here. Again, what's kind of hidden in the chart, and this happens sometimes in charts, they don't give us any kind of descriptor of the individuals. These are just all variables, right? The province the variable lives in, the gender, number of languages spoken, hand in his height, wrist circumference, and preferred communication is important, but none of these are describing the individuals. The individuals are left empty in here, and that's okay. That's okay. There's nothing wrong with that. So let's go again. We have some categorical data, where these people live, the provinces of Canada. Canada doesn't have a state, it has provinces. The genders, the handedness. These are all categorical preferred communication. Where everything else is quantitative, right? And I guess there is something to look out for here. You might notice here, there is some weird data in this chart, this 65. This is significantly smaller than everyone else, even though this height is not really significantly smaller. So when you're doing statistics, you do need to check for errors. The one way to check for errors is to see if there's any data that which doesn't really match up to what it's supposed to do. But that's just a specific example in that chart. Next, we talk about different types of quantitative data or quantitative variables. Discrete quantitative variables has holes in it. It's just a fixed set of values with space between them. So, excuse me. One example of discrete quantitative variables would be in this chart down here would be the seconds column. So if we're talking about discrete quantitative, this second columns would be an example of that, right? Because between 1 second and 2 seconds, there's really nothing. We think of that as a gap, right? Where the other numerical columns, the other quantitative columns here, have decimals. And whenever we see decimals, 99% of the time is going to be a continuous quantitative variable. And continuous, just like in calculus, there are no spaces. We can draw without picking our lineup. It continues on, right? So what height comes after 1.87? Well, it's like 1.8701 or whatever, right? Like we can fill in all the gaps. Same thing with speed. We can fill in all the gaps. Okay. So there is an example of continuous and discrete quantitative variables. We do not talk about continuous or discrete for qualitative or categorical variables because they have nothing to do with numbers. Now, displaying categorical data. We're going to focus in on categorical data for a bit. Categorical data puts individuals into categories. One thing people might be concerned about is the frequency that they're in these categories. So here's an example of ways we can display that data using a frequency table. So what's important here to note is that this guy is the data being collected, right? This guy is a frequency table talking about that data, right? So it just tells us the categories, all right? Cell phone, Facebook, in-person text messaging. Tells us the categories, tells us how frequent each category happens. And often with a frequency table, we make a bar graph. So when we make a bar graph for a frequency table, I need a little more room. We put our preferred methods across the bottom. So we have cell, we have Facebook, we have person, in person, and we have, we'll go SMS for text. And we have our frequencies up the side, so 1, 2, 3, 4. And then we can draw our bar graph, right? Cell, Facebook, in person, text message. Okay, so there's one way to display this data. And whenever you make a chart, whenever you make a graph in statistics like this, you do need to label your axes. So this is preferred method. And this is number of people. All right, so if you don't label your axes, you are wrong because you cannot really, you don't know what your chart is talking about. All right, so that's a frequency table, and it turns into bar graphs. Then we have a relative frequency table. And a relative frequency table is kind of more interesting when we want to talk about percentages. We want to talk about percentages, which lets us, for instance, compare different size samples, right? So here we kind of have a very small sample. Say we wanted to compare it to a very large sample. It wouldn't make sense to say like, oh, well, Facebook text messaging is more favored in this big sample because 800 people did it, right? Because maybe it's just the same amount of favoring, even though there's just more people reporting. So we make things called relative frequency tables, right? And the way to make a relative frequency table is you just take your frequency table and you divide by the total number of responses. Here, if we add all these numbers up, we get 10. So we just divide by 10 responses here and we get a relative frequency table. What can we do with a relative frequency table? We can make a pie chart. We can make a pie chart. Okay. And when we make a pie chart, we want to, kind of do our best to make it pretty good. Make things kind of accurate. This will be like text, in person. I know I changed my things here, but I'm running out of room. This would be Facebook, and this would be cell phone. And they're pretty close, so this is 20%, 40%, 30%, and 10%, right? So we can kind of include all this data in our pie chart. We can color it in if we want. But relative frequency tables become pie charts. Okay? So here is your first problem for your async assignment. I want you to make, from this chart, I want you to make a, this is an example of a frequency table. I want you to make a relative frequency table, right? A relative frequency just by dividing by the total. And I want you to make a bar graph and a pie graph. Right, so do each of those for this data set. Next thing we have to talk about is a two-way table. It allows us to compare different ways of categorizing people. So for instance, here we have a table which describes whether or not someone's a member of a club and whether or not they use a snowmobile. We can compare the two answers to these questions using this two-way table. And what it turns out is useful is to make a kind of add some extra margins to this table. Add some extra margins to this table. By just like summing these numbers up, it makes it a little more useful. So if I add up 445 and 212, I get what? 657, 497 and 77 is going to be 574, 279 and 16 is going to be 295. Now if I add straight down the columns, I do 212 and 77 is 279, 289, 299 and 6, 3305. And then this is, oh boy, big numbers here. 445 and 497. That's 500. That's 942. 942. That's 1142 and 79. That's 1151 and 70. That's 1221. Right, and then if I add across, I get 1527, and if I add down here, I should also get 1527. Might have made an arithmetic mistake. But kind of augmenting this two-way chart this way makes it easy to answer things like what percentage of people surveyed do not own, what percentage of people surveyed own a snowmobile, right? So here's the, here's the total number of people have surveyed. Here's the people that own a snowmobile. So I can just answer that question I just said out loud, provided I did all the arithmetic correctly. Okay. Now, let's talk about how we can represent this data. Two-way table tends to be represented in two different ways to tell you the exact same information. We can do a grouped bar graph or a stacked bar graph. The grouped bar graph here is over on the left. We just use the tops of our columns to split us up into no and yes. And then we just make little bar graphs for each of the three categories on the left. We could also do this by stacking, as we do here on the right. Again, splitting up into whether they're an environmental club or not. Okay. And then finally, these are relative frequencies, because we see we're out of a percent here. So these are relative frequencies. Okay. And finally, here we have something called a mosaic graph. And it looks a lot like actually our stacked bar graph, except the size of these two is represents the size of these two columns, right? So since the no is much bigger than the yes, the no is much bigger than the yes. All right. And then finally, there's an association between two variables. If knowing value of one can help predict the value of the other. This is in two-way charts. So for instance, having some issues with my Zoom here. For instance, if I knew that, being a member of the environmental club meant you were more likely to own a snowmobile or something, that would say there's an association between being a member of the club and owning a snowmobile. If we were to look at our, say, stacked bar graph, we can see here that this would be an example of there being no association, because the 2% bar graphs are exactly the same. So knowing the answer to the whether or not you're in the club does not tell you anything about these graphs. Okay, so some simple graphical information for statistics. what do I want you to do here? Okay, so for in the problems, I want you to do 6, 7, 8 right here. 6, 7, 8 right there. Here I want you to do 9 and 10, which refers to this chart. Okay. Here I want you to do 14 and 15. Here I want you to do 25, A through C. Here I want you to do 26, A through C. And here I want you to try 43. Now 43 is a tricky question, but do your best. So, gentlemen, I'll see you when I see you.